Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we are required to evaluate the projections of the oblique planes which happen to be inclined to horizontal plane as well as the vertical plane. So here we have got Pentagonal Lamina ABCDE. It has got its plane inclined at an angle of 45 degree with respect to the horizontal plane. Now since the first angle of inclination of the surface of this lamina happens to be with respect to the horizontal plane, so therefore to begin with we are going to assume that this pentagonal lamina happens to lie into the horizontal plane. That is, we are going to obtain the true shape projections of this particular lamina onto the horizontal plane in the top view projections over here. And this top view true shape projection will be obtained below the XY reference line. Whereas when we are going to look at this lamina from the front view, so we are going to obtain the edge view of this particular lamina onto the XY reference line. So another information which is available with us, that is the line joining the vertex D to the midpoint of the base AB. So this line which is going to join vertex D, that is, we can say that this is the vertex D and this is the opposite edge AB. So we can have A, B, C, D and E points of this hexagon. This is the base AB corresponding to this pentagonal lamina and this is the vertex D corresponding to this lamina. So this perpendicular edge now we are going to talk about. So this perpendicular edge which joins this vertex with the midpoint of the base over here. So this line which is going to join vertex D to the midpoint of the base, it is inclined at an angle of 30 degree with respect to the vertical plane. So we are required to draw the orthographic projections of this particular oblique lamina. Now let us discuss about the orientation of this lamina with respect to the vertical plane. So if we have this orientation of this lamina, now what's going to happen if we are going to incline this with respect to the horizontal plane either in this orientation or in this orientation. So we will find that this edge will still remain as true length projection on the top view, but there will be foreshortening of this edge, this edge, this edge and this edge as well. And besides this, there will be foreshortening of this line which is going to join the vertex D and the midpoint of the edge B. So here the apparent length will be available with us in the top view projections when the lamina will be inclined with respect to horizontal plane at an angle of 45 degree. So here we have been provided with that the true length of this line joining vertex D to the midpoint of the base AB. So this is inclined at an angle of 30 degree with respect to the vertical plane. So here we are going to obtain the apparent length of this line which is going to join vertex D with the base AB over here. Whereas if we draw this particular pentagonal lamina in this orientation, now you see, if we are going to incline this pentagonal lamina with respect to the horizontal plane at an angle of 45 degree, so it will be resting on ground on its corner over here. So onto the top view, we are going to obtain the apparent shape of this pentagonal lamina in which all the 5 edges, they will be foreshortened. Why? Because all these 5 edges of this particular pentagonal lamina, they will be inclined with respect to horizontal plane. But this particular edge, you can see this line which is going to join vertex D with the midpoint of the base AB. So this line, it will be still parallel to the horizontal plane. So into this top view projections which we have obtained corresponding to the surface of the lamina, which happens to be inclined with respect to horizontal plane at an angle of 45 degree. This vertical line, it is still obtained as a true length, and in the second iteration, this vertical line we are going to draw at an angle of 30 degree with respect to the vertical plane. That is, the top view projections we are going to reorient in such a way that this line, which is a true length, and it is joining vertex D with the midpoint of the side AB. So the true length of this particular line will be drawn at an angle of 30 degree with respect to the vertical plane. So this is the appropriate orientation of the pentagonal lamina, whereas this is the incorrect orientation of this pentagonal lamina. So let us evaluate the orthographic projections of the pentagonal lamina. Now, to begin with, as we have discussed, the first angle of inclination of the plane of the lamina or the surface of the lamina happens to be with respect to the horizontal plane. So to begin with, we are going to assume that this pentagonal lamina will be resting onto the ground or onto the horizontal plane. So the true shape of this lamina, this will be obtained in the top view projections onto the horizontal plane, and these projections will be drawn below the XY reference line. Now we have drawn this pentagonal lamina A, B, C, D, E, in which we can see AB happens to be the base of the lamina, and D, it is a point or a vertex which happens to lie just opposite to this particular base, and the edge of the lamina happens to be 35 millimeter. So the true shape of this lamina has been obtained in the top view projections onto the horizontal plane. Now when we look at this lamina from the front side, so all the 5 points A, B, C, D and E of this lamina will be projected onto the XY reference line, and we are going to obtain the front view projections corresponding to this pentagonal lamina onto the horizontal plane or the XY reference line. Having obtained the edge view projections of this lamina onto the horizontal plane, now we have to incline this edge view or the surface of the lamina at an angle of 45 degree with respect to the horizontal plane. So we have marked this orientation line at an angle of 45 degree with respect to horizontal plane. Now we know the distances between E dash and A dash, A dash and D dash, D dash and B dash, and B dash and C dash. So all these distances, they have been translated from the first edge view into the second edge view. Now into this edge view, we can see that all these points E1 dash, A1 dash, D1 dash, B1 dash and C1 dash, they have the same distances as they were located in the previous elevation projection view which was obtained onto the XY reference line. Only difference between this view and the previous view is here the edge view has been reoriented or realigned at an angle of 45 degree. Now having obtained the front view projections of this lamina, when the lamina is inclined with respect to horizontal plane at an angle of 45, now we need to obtain the corresponding top view projections of this particular lamina below the XY reference line. So now we have drawn horizontal projector lines through all the 5 points of the top view which we had obtained previously, and now we are going to draw vertical projectors through each of the points of the elevations which we have obtained over here. So the vertical projector through A1 dash and horizontal projector through A. So they intersected this point, giving us the resultant point as A1. Similarly, the vertical projector through B1 dash and the horizontal projector through B, they provide us with the intersection point as B1 over here. Similarly, the vertical projector through C1 dash and the horizontal projector through point C. So the intersection of these two projectors, they provide us with the location of the point C1 in the top view projection. Similarly, the intersection of the vertical projector obtained from the point D1 dash and the horizontal projector drawn through the point D it provides us with the point D1 in the top view projections. And finally, the intersection of the vertical projector through point E1 dash and the horizontal projector drawn through the point E. So this provides us with the location of the point E1 in the top view. So this way, the top view projections A1, B1, C1, D1 and E1, they have been obtained. And once we join all these top view projection points over here, the apparent shape of the pentagonal lamina in the top view has been obtained over here, in which A1, B1 is the apparent length, B1, C1 is the apparent length, C1, D1 is the apparent length, D1, E1 is the apparent length, and E1, A1 is also the apparent length. But the special characteristic of this apparent shape projection in the top view is that in this view, we have been able to obtain the true length projection corresponding to this vertical projector line, which is going to join the vertex D1 with the midpoint of the edge A1, B1 over here. So this is the midpoint of the edge A1, B1, and this is the vertex which is opposite to this base over here. So this edge is still the true length. Why? Because this line is parallel to the horizontal plane. So this way we have been able to obtain this line which is going to join the midpoint of the base and the opposite vertex D. Now this line, it is further inclined with respect to vertical plane at an angle of 30 degree. That is, this plan projection view we are required to transfer at an angle of 30 degree to the vertical plane in such a way that is onto this orientation projection line which we have drawn at an angle of 30 degree. This line should be lying over there. That is the line which is going to join vertex D1 with the midpoint of the edge A1, B1 over here. So how that can be done? Now once again, using rectilinear distance method, we are going to transfer this pentagonal plan projection view into this position over here. Now how that can be done? We have this rectangle, please check, which we have drawn to inscribe this pentagonal apparent shape projection over here. So we know that this is the rectangular projection, and we also know that at the midpoint, if we draw a parallel line, this edge will be obtained, and at a distance of this much from the point D, if we draw this vertical line, so all these points we can obtain over here. Let us draw this rectangular box which is going to inscribe this pentagonal top view projections in such a way that this midpoint line, which is corresponding to the true length of the point D1 with the midpoint of the edge AB. So this is this particular edge which is a true length. So we have drawn this rectangle in such a way that half of the rectangle will lie on left side, half of the rectangle will lie on the right hand side. So half of the rectangle lies on left hand side and half of the rectangle lies on the right hand side. Why? Because now the focus is there onto this line which is a true length. So this line has been obtained. So now we know that from this point you measure this distance and you measure this distance, points A and B, they can be located. So please check, we measure this distance, we measure this distance. So points A1 and B1 can be located over here. Similarly, after drawing this line, we know that from this distance and this distance from this particular line, so C1 and D1 can be located, and at the midpoint, point D1 can be located. So now we have been able to measure the rectilinear distances and transfer this apparent shape of the pentagonal lamina into this position in such a way that the opposite vertex D2 joining with the midpoint of the edge AB. So this line happens to be inclined at an angle of 30 degree and this line happens to be true length over here. So this way, so this apparent shape has been reoriented or rotated with respect to vertical plane at an angle of 30 degree. Now having been able to obtain the apparent shape top view projections of this oblique lamina, which happens to be inclined to HP at an angle of 45 degree and it is inclined to the vertical plane at an angle of 30 degree. So this top view has been obtained. Now the corresponding front view projections of this pentagonal lamina have to be obtained. So how we can obtain it? So we can obtain the corresponding front view projections of this oblique lamina when we draw the horizontal projectors through the elevation projection points over here, and now the corresponding vertical projectors we are going to draw upwards. Now the points of intersection of the corresponding projector between the corresponding points over here, they will provide us with the front view projections of this lamina into the vertical plane. So let us start with this. So from point A2, if we draw a vertical projector, we are going to extend it above the XY reference line and extend it up to the point such that it is going to intersect with the horizontal projector which has been drawn through the point A1 dash over here. So this is horizontal projector through A1 dash and vertical projector through A2. Wherever they intersect, we obtain the point A2 dash. Similarly, the horizontal projector through point B1 dash and vertical projector through the point B2. Wherever they intersect, we obtain the front view elevation projection corresponding to the point B2, that is B2 dash. Similarly, the intersection point of the vertical projector drawn through the point C2 and the horizontal projector drawn through the point C1 dash. So this is obtained as point C2 dash over here, and the vertical projector through D2 we have drawn and we have extended it up to the point where it is going to intersect with horizontal projector drawn through the point D1 dash in the elevation. And finally, we have the point E2 over here. So from point E2, we have drawn a vertical projector in the upward direction, extended it up to the position where it is going to intersect with the horizontal projector line which has been drawn through the point E1 dash. So this is the location of E2 dash. So this way, the front view projections of A2 dash, B2 dash, C2 dash, D2 dash and D2 dash points, they have been obtained. So once we join these points, we are able to obtain the front view apparent shape projections of this pentagonal lamina, which happens to be inclined with respect to HP at an angle of 45 degree and VP at an angle of 30 degree. So this way we have been able to evaluate the front view projections as well as the top view projections of an oblique pentagonal lamina which is inclined to horizontal plane as well as the vertical plane. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate the orthographic projections of the pentagonal lamina which happens to be inclined to both the reference planes, that is HP and VP. So we are going to continue with further discussion regarding few more illustrative cases of the orthographic projections of the planes in the coming lectures. So thank you very much. Thanks a lot.